Of the 2D commands. Now we will move ahead. So till here editing command we have discussed. Now we will today see what are the constraint and what are the use of the constraint. See, generally the constraints are in other words we can say a relation or we can say boundaries. And for example, when someone says that you are constrained in your home, means you are restricted not to go from out of your home. Okay, so it's a type of one type of restrictions that will monitor you, or you can say it's also a type of relations. So here there are different types of constraint. When there is a, we can use it with the help of two elements also, and some of the constraint we can use on single element also. For example, here the first constraint we have is called vertical. Now where it is used in order to create any of your line which is at any inclined position. You, if you want to create it exactly vertical, you can create your line vertical, or you can also align two vertices, means 2 points in vertical direction. For example, we will take here two circles. For example, there is one circle here I have drawn here and one circle here I have drawn here. Now we will use this vertical constraints. For that case you need to select two vertices, or for example this one and this one, and now you can see here this circle which was before applying the constraint was at this position, moved here and aligned with this center. Okay, so here you can say that both the circles have vertical center points aligned. Likewise, you can use with your line also. For example, here if you have created any of your line in any of your angle, then you can go with the vertical constraint in order to make this line completely vertical. So for that case you need to select the vertical constraint and just you need to select the line, and you can see here it is vertically aligned. In the same way, likewise we have seen vertical constraint, there is also a horizontal constraint. For example, I am drawing one circle here, and let's also make some of line here. Now let's just hide the dimension temporary. Now you can see that here the points, that is the center of this point and this point have some specific gap here. Now if you want to align the center point in the horizontal line with respect to the center, you can go with the second constraint, that is horizontal constraint. Now you need to select both the center points, and you can see here both the lines have been arranged in horizontal direction. Now I will make just Ctrl Z and again use the this one. So at this time I will select this as a first and second as this. Okay, the result is the same. So when any specific distance is given, for example, if I have specified some distance here, let's show the dimension here, and if I make it here a specific distance between them, let's make it 5 mm. Okay, so now there is a specific gap between these two, and now if you apply the constraint between this circle and this circle, you will notice that this circle has not been moved, and instead this circle has moved here aligned with this. So the specific entity that you have defined any specific value will be used as a reference, and another entity that you have selected will move according to that reference. So we have seen here the horizontal and vertical constraint. Now it's time to see the third, that is perpendicular. Now where it is used, so the perpendicular constraint is used where you wanted to make any of your line perpendicular to any other line. For example, here we have two lines here, one is the vertical and here the second one is at some angle. But if you want to make it perpendicular to with respect to this line, You just need to go with the perpendicular one and select this line and select this line, and now you can see here this is at the 90 degree. Likewise, there is another constraint called parallel. Okay, here we can see that parallel constraint is there. So when you required, for example, here I am creating one line, okay, and I specify the angle between these two lines as a 60. Now it's a strong dimension because we have specified the value. Now I create one more line from here like this. Now if I want to make this line parallel to this line, I will go with the parallel constraint, select this line and this line. Now you can see here if there is a 60 degree, here the same distance has been angle has been applied like this. So we can make any of the line parallel in nature, perpendicular in nature, either horizontal, vertical, as per our need. So here also you can see the constraint is shown here, that is the parallel sign is there, and if you keep your mouse over this, then you will have one number, that is 1, which is identical to this constraint. So you can understand that there is a constraint between this line and this line. Likewise, if you want to use any next constraint, for example, here is the equal constraint. Now what it will be used for? So equal constraint generally makes the distance equal, or we can say a radius equal. So furthermore, if I give a specific radius to this one, for example, here I will give 5 and a specific distance to this one, that is 8 mm. Okay, so we have two defined object here. So if I want to make this circle and this circle equal, then I will just go with the equal constraint and select this circle and select this circle, and you will find that this 2.54 will get bigger like this. Likewise, you can go with the lines also. For example, if you want to make any of the line here 8 mm, then select that line here. Okay, go with equal and then select this line and select this line, and you will find the distance has been 8 mm here. Then comes here the symmetric concept. Now what is symmetric ones? For symmetric constraint you need let's put a center line between them, and if I specify this distance as a 7 and let's make this distance as a 3. Now here there is a gap uneven from the center line. Here you can find 7 mm while here 16.26. In order to make this symmetric, means both the circles will have the symmetric distance from the center line, that is 7 mm from left side, likewise 7 mm from right side. So in that case you can go with the symmetric. Here you can see that in Q line a straight reference lines and two vertices are need to be selected. So we will select this straight reference line and then select this point and this point, and you will find here this second circle has changed its position with respect to center line. Now you can observe here both the distance are same, means they are equally at a distance of 7 mm from the center line. So if I move this circle, okay, first cancel this command, and if I move this circle, automatically that circle will also move, okay, and will keep the same distance with respect to center line. So this is the use of the symmetricity, this constraint. Now we will go with a tangent. Now where tangent is used? Tangent is used where you want to make any of your arc tangent to any of your circle or any line to get tangent. For example, here we have seen line tangent. So if you create line tangent, how it will be created? For example, if I create a line with respect to this circle and this circle, then here you can see it is tangent. Tangent simply means touching. Okay. And if you make it any of your circle, then you can't go with this option. Then at that time you need to select this tangent constraint, and now you can create any of your circle tangent over another circle. Now if I just drag this circle, now you can see it is going tangentially on the surface of another circle. If I make it, let's here make it is equal. So if I just go with this circle, you can see here, if I fix this one, and then I will go with this one, so you can see here the circle is moving around the periphery of second circle. So this is called tangent relation. Likewise, you can create any of your arc here. For example, 3-point arc. Let's start here from anywhere from the circle, then end here, and you can just give your like this, okay, anywhere, and now you can add your tangent here. For example, this circle and this line. So here you can see tangent has been shown here. Likewise, if you want to make this circle and this line as a tangent, now completely this arc is tangent to both the circles. Now remaining you can just delete it with the delete segment, and you will have a desired shape like this. Okay, so this type of shapes you can create with the help of this constraint. Now next constraint we have is the midpoint. Now what it will do, it will align your arc, or you can say your circles, in the mid of the line. So let's see that. For example, we have one line here, okay, and one circle here and one circle here. Now you can see here there is a midpoint of, there would be a midpoint of this line, okay, somewhere here. Now if I use the midpoint one, what I need to select, I need to select the point and a line of arc, okay, a start point and a line or a arc, means here it would be the start point and here it would be line. So it will directly place your circle in the mid of the line. Likewise, if you want to select this point and any of the other line, then you can see here the line has been arranged here in the mid of that object. Then comes simple coincident. So coincident means it will match 2 points, or you can say touch 2 points. For example, here if there is a line, okay, like this, and let's take one circle also. So now if I want to have this end to be here on this end point, okay, firstly this display, okay, then I will go with the coincident simple. I will select this point and this point, and you will see here both the point has been matched. Likewise, if I want this circle at this top, I will select this circle and this point, and it will touch that point. So here you can see one symbol is there, that is the coincident vertices. Likewise, here is there is a symbol of equality with 2. So where is 2? Here you will find equality 2 means this circle and this circle have the equal radius. Likewise, this circle number 4 and number 4, this one has equal radius. So these are the different type of constraint. I hope you understand all the 9 constraint here. Then if we move forward, we have a group of dimension here. From here you can just put any of your dimension. First I will just visible the dimension. Now here you can see there are some weak dimensions are there. Here you can see there is an angle between this line and this line, inside angle. But if I don't want this inside angle, I want it to be like this angle. Then you can go with the dimension, select this line and click anywhere somewhere here. Now you can see that this inside dimension has been removed and one your desired dimension has been added. Now I can make change as per I want. Likewise, if you want to give any of the radius or diameter, you can just give it. For example, let's create one circle here. Now here by default a diameter has been given, but I want to give a radius. Simply just select one of the edges and press here. Now there is an radius mentioned here, so you can see R4. Okay, so any of the dimension you can give just by clicking 2 points. Okay, if you want to give the gap between this circle, now here you can see that there is a reference diameter from the axis line, but you don't want this dimension. Okay, simply you want the circle with respect to this point, then you can simply go with selecting this point and this circle and middle mouse button press here and you will find here distance between them. You can make it 8. So here your point has been displaced according to this. Okay, now here we have some different options here. So this is the perimeter. In order to provide any of your perimeter, that is the total length of the chain. For example, I have one chain here. Okay, so here we have a chain. Now just select the perimeter here and select the dimension which you need to driven by the perimeter. For example, here. Okay, you can make it as you want, like 100. So here you can see a perimeter is shown here, 1000, sorry, 100 perimeter is shown here. So this is the way to include your dimension as you want. Likewise, if you want to a reference dimension, for example, here it will show as a reference. Then comes here some inspect group. So what it will be used for, the inspect group is nothing but visualization group. The first one here we have is overlapping geometry. So first of all we will just clear all the sketch here. Now we will draw some circle here, draw some line here. Okay, like this till this, and draw one line here and one line on this line only, like this. Okay, so I have here overlapping element here. Okay, so if you want to highlight that overlapping entity, you can just select this overlapping entity, and once you select you will see that where the in your sketch where there is a overlapping entity. So here you will find overlapping entity, just select it and it will highlight it in purple color. And then second option we have highlighted point ends. If you just deselect this, then no, whatever your highlighted points that are shown in red color, which are end points, will not be highlighted like this. So open ends are highlighted with these options. So it will make you clear that this drawing, or you can say this sketch, is open and is not fully closed. And here the third option you have is shade closed loop. If you deselect this, your closed portion will not show any of your shadow part, but if you just make it turn on, then you will see which is completely closed. Likewise, if I want add one line here, then it will also be seen in shaded point, like this. So it is completely closed here, both the sketches. Then comes, there is an intersection point. So if there is any line which is intersecting any of the point, then it will get highlighted with respect to this. So for that case, you need to select this intersection point, and now here you need to select two entities. For example, I select this and this, and here you can find intersection point has been highlighted here, and coordinate also x and y has been shown here, that is 17.75.79 and 56.78. Now the another option you have here is a tangency point. Likewise, if you have any tangent line or tangent circle, it will also be seen here. For example, I will make circle here tangent. Okay, so here it has tangent point. So in order to see where it is tangent, if you don't find here the tangency, then you can check it with this option, tangency point, and here you can see the point has been highlighted here, and here there is an angle of tangency also given 151 degree, and also there is a curvature of primary selection, that is on which two circles there is a tangency. Likewise, if you want to inspect any of the entity, for example, what is the length of the line and what is the position of this line, you just simply have to select the line while selecting this on entity, and here you will find a window which will show you the entity ID, that is the 101 is the entity ID for this particular line, and here we have entity type, that is the line, and length of the entity, that is 40.70, and the slope, that is the degree, it is as it is inclined. Okay, so it is a 147.71 degree. Likewise, if you select any of your circle as an entity, it will go with that particular entity type, that is circle. You will see here radius, and then you will see here length of entity. Now what is the length of entity? Though it is a circle, okay, it will always indicate a radius, but once you cut out that circle from any of one point, and you just make it straight. Okay, for example, if I cut the circle from here, and I will just take this point here, align and horizontally align like this, and I make this circle another point like this, then it will create a simple straight line. If you open this circle from any of the point, then that length will be shown in the entity. Okay, so we will keep till here. I think now most of our 2D commands has been over here in Creo. From next lecture we will start our 3D modeling. Okay.